Hello all. Today we are going to learn about reinforcement learning and its algorithm. So brief introduction about me. I have 5 years of experience in data science and analytics, and I have a specialization in both machine learning and deep learning. And I have worked on different domains such as finance, manufacturing, retail, and others. So today's agenda review, we'll first see what is reinforcement learning. Then we will understand the concept. Then we have to see the types. Then we will try to understand its algorithms. Then we will see the application, merits, demerits, and thereafter conclusion. So what exactly is reinforcement learning? Reinforcement learning is the process of teaching a machine learning models to make a series of decisions. Particularly that means that it is a teaching a machine learning model that it has to make its own decision based on complex and uncertain environment. So it is just nothing but it is a game like a situation where a computer does a trial and error, and finally it will try to give the best possible solution and to make the machine do what the programmer wants. The artificial intelligence is rewarded or punished for the action it takes. Its goal is to increase the overall reward. That means whenever it gives a wrong prediction, then it will be taken as a penalty. And if it does a good prediction, then it will be rewarded. So this will be a continuous process, and at the end of the day, goal is to increase the overall reward. That is the efficiency of the reinforcement learning model. This is about basic of reinforcement learning. Now let us understand some concepts. Okay, as I said earlier, there will be some environment, agents, and rewards. Okay, so what exactly is agent? Agent is nothing but is a fictitious entity that acts in a given environment in order to obtain reward. That is nothing but agent is like any machine learning algorithm or robot, anything. Okay, so environment is nothing but a problem statement, a situation that an agent must deal with. That is called environment. That is a problem statement. Reward is if you give a positive result, then it will be rewarded. If you give a negative result, it will be also be rewarded in a negative way. The state is nothing but the situation which in the current environment at any given moment. What is the state? So that is called a state, and it is represented by S. And policy. Policy is nothing but a strategy used by the agent to determine the next action to take based on the current state. Policy works like based, for example, if in current state of time I am doing or I am achieving certain number of accuracy. So whether I have to increase or I have to change the parameters, all this is done by policy. Okay. So and what is value? Value is represented by V, and it is the expected long-term return with a discount in comparison to the expected short-term reward. So it is nothing but it's like a sale where a long-term benefit or profit is taken instead of considering having a discounted short-term reward. So it is a long-term overall 1 year profit rather than a short-term 1 day profit. So this is known as a value. And there are some other concepts like value function. It specifies a state's value, which is the total amount of reward after agent should be expected. So it is not total reward how much you are going to get after a reinforcement learning completes its task. So model of the environment, it mimics the environment behavior. It helps you to draw the conclusion and predict how the environment will behave. Based on the environment, model going to predict or mimics it. And model-based method, it's a model-based approach to solving the reinforcement learning problems. And Q value or Q action, this is another one. Q value and value are similar. The only difference between the two is addition of a new parameter as a current action. So Q value or action value network, it is the same. It's a value function, and where it is saying that one is a key value and another is action value. Based on the action, it will give the value. So now let us understand the types of reinforcement learning. So basically there are a few types like positive and negative. Positive nothing but if it is given positive, then it is rewarded like that. So it is defined as an occurrence that occurs as a result of specific behavior. It strengthens and repeats the behavior more frequently, which improves the agent performance. So it is like a continuous or continual learning. Based over the period of time, the model accuracy is going to increase. This type of reinforcement enables you to maximize the performance and sustain the change over a longer period. Excessive reinforcement, on the other hand, may result in a state of over optimization, which can influence the outcome. That means we have to do a calculated number of times of revisions for the learning. So once we achieve our objective, then there no need to give any over training or excessive reinforcement. So in that case, it is better to stop that. And if it gives excessive reinforcement learning, then other hand, what will happen? The outcomes may be wrong. And another type is negative. Negative reinforcement is described as a behavior strengthening that occurs as a result of a negative condition that should have been stopped or avoided. Means while first at this initial stage, like for n number of steps, once it is started to show negative result, like for example in percentage minus 10 percentage, if you have not stopped it, at that time the negative reinforcement learning is minus 10%. But if you let it learn itself, then it will compound. Maybe after 10 iteration, the total loss negative learning is maybe around 20%. So it would have been better if you have earlier stopped it at a negative 10% rather than doing it minus 20%. So this is about a negative types of reinforcement. Now let us understand this one source. Okay, here how an environment, agent, and action, all other concepts work here. Okay, before that, let us try to go through these terms. Okay, now learning the models of reinforcement, how it happens. Okay, there are two. One is Markov decision process, and another is Q-learning. What is Markov decision process? In Markov decision process, it's basically a mathematical model. Okay, it uses a mapping solution. Nothing but it takes a mapping of the environment, state, and agent and reward. Okay, so based on that, it tries to map and tries to learn. Okay, and this is known as MDP. That is nothing but Markov decision process. Okay, so typically there are, as I told, okay, action will be there, set of steps S will be there, and reward, okay, and policy N, and value V. Okay, what happens? The agent is here. Okay, the action begins, and it will learn everything in this environment. Okay, once it learns, if it is good enough, okay, it will give the rewards. Okay, if it is wrong enough, it will give a negative reward. So here in that case, the negative reward keeps on happening. And in the state, okay, here our learning continuously try to improve. So this is in the loop, continuous loop. So it goes on like that, so that our when until and unless our objective is met, then this cycle moves on. Once the objective is done, then it will take. So now let us understand a Q learning. What is Q learning? Q learning is a value-based technique of informing an agent about which action to take. So in earlier Markov steps, what it is not going to give any value, it is going to learn by itself. But in here, what happens? We'll give a value, okay, certain value to which action it should take. Okay. So let us understand, and in the following example. Okay, so this is the same graph I have taken for our easy understanding. For example, there are like a building which has 5 rooms that are connected by a doors. Okay, each number is number 0 to 4. Okay, the building exterior can be one large open space 5. Okay, door numbers is 1 to 4, and which is leading to the building from room 5. Okay, what happens? See here. Following that, you must assign a reward value to each door. Okay, that means whenever it learns, it goes to the door, then we have to reward it. Okay, otherwise, will not give a reward. Okay, doors that lead directly to the goal are with 100 points. Doors that are not directly connected to the target room will no reward. So when the door which is connected to the other door, then we'll give 100 points. Otherwise, if the door is not connected to another door, then we will not give any reward. Okay, that is the point. Because why doors are two-way and each room has a 2 arrows. So for example, you can see this. This is how they are connected to each other. Okay. If since this 3 and 5 are not connected, so there is no reward at all. Okay. For example, in 1 and 2, okay, they are not connected. There is no reward. In 0 and 2, there are no reward. But 0 and 4, they are connected with each other, then there is a 100. Similarly, goes along. So every arrow in the preceding image represents an instant reward value. So this is a reward value. Okay, this is a Q-based learning, means value-based learning. Okay, we will give a value as 100 points as a reward if it is connected to each other. So in this way, we can do a reinforcement learning based on a Q value. Okay. How to implement a reinforcement learning? Well, here is the answer. There are three approaches to implementing the reinforcement learning. One is value-based, policy-based, and model-based. Okay. So in the value-based, what will happen? We should try to maximize the value function using a value-based reinforcement learning. Okay, in this method, the agent anticipates a long-term return of all current policy states. So it is nothing but we are going to give a reward based on its value. Good, like a positive result, then we will reward. Otherwise, negative result, we will not reward. Okay. What happens in policy-based? In this type of reinforcement learning, what happens? You try to create a policy in which every state helps you gain the most reward in the future. Means it is a end goal. Okay, we will try to train the model at the beginning step. Then our aim is to get the reward at the end. And also in this, there are two types of policy-based algorithms are there. One is deterministic and another is stochastic. Deterministic in actually for any state, the same action is produced by the policy. It is like in a loop. Okay, the same action is going to be produced. But what happens is stochastic. Stochastic is a function. It depends on A and S. Okay, every action has a distant possibility. Okay, which is determined by the following equation. This is nothing but this is the policy P and every action A, and this is a state. So every action is determined by the state which is governed by the policy and its action. So it is not like it is in a same action is produced by the policy law. It is not like a deterministic. So it's based on action and state and its policy. Okay. So another third one is model based. It is nothing but we have to create one virtual model. Okay. Then in this environment, the agent learns how to perform specific tasks. It is basically it is like a robot. Okay, where we will try to build the entire model. Then based on that, it will try to learn specific tasks. For example, picking an object. Okay, moving from A to B. So this is like that. And another way of obtaining the reinforcement learning is model-free versus model-based learning. Model-based learning seeks to model environment before selecting the best course of action in view of its learn model. In model-free learning, the agent estimates the best policy through trial and error. So it is just like before doing it, it will try to observe whether we have to go this way or that way. For example, from point A to point B, it will try to have a decision based on its past experience. It is known as model-based learning. In model-free learning, it will try to move in a random place until unless it reaches its B point A and B. It will do trial and error, finally it will reach the point B. So that is a model-free learning. Okay. Now understand a bit better about model-free learning. Okay. Policy optimization, Q learning are the two main approaches regarding the model-free reinforcement learning. Okay. Policy optimization are policy iteration methods, in which what will happen is the agent directly learns the policy function that maps the state to action. The policy is established without the use of value function. Here there is no value function is used. Okay. So it is based on optimization. Okay. It directly learns the policy function that maps the state to action. It directly learns, and there is no value to the previous functions. Okay. It is important to note that policies are classified into two types. One is deterministic and stochastic. This we have discussed earlier. Deterministic and stochastic. It is the same way. Okay. So deterministic policy maps the state action without uncertainty, as we discussed earlier. Okay. So next is asynchronous advantages at okay. So what happens in asynchronous? Several agents are trained in their own copies of the environment. It is just like a nano model. Okay, there are n number of nano models will be trained, and they are allowed to reach to the target. What happens? The fittest one is going to reach the end goal. Like for example, out of 100, 5 are reached. So those wise learning are taken into this in this asynchronous advantage. Okay. So in second one is advantage. Similarly to the PG, where the update rules used to discount the returns from a set of experience in order to tell the agent which actions were good or bad. So in this case, advantages will come. Okay, this action is good. Okay, so this way you have to go. So this action is bad. So we are not need to take this step in the future. So that is how it goes. Okay. Another one is actor critic. This is it combines the advantages of both approaches. So it is asynchronous plus advantages. It combines the both, and it will try to do the policy iteration, and it will try to learn with the estimated value function VS and as well as a policy P. So in this case, what happens now? The network will estimate the value function, how good it is or bad, then it will try to learn. The final one is that like TRPO can operate and discrete or continuous action spaces. Okay, PPO and TRPO are the both driven by the same question. How can policy be improved without jeopardizing the performance? Means when a performance is attained at a certain level, for example, it has 50% at the initial stage. Our now main objective is next level of training, it should increase to 55%, need not to go for 45%. So this type of learning is known as proximal policy optimization. Okay, that's nothing but PPO. PPO improves the stability of actor training by limiting the policy updates at each training step. So it will have a limited training steps at each step. Okay, so that our policy optimization increase in the positive direction, not the other way. So PPO gained popularly after OpenAI made a breakthrough in deep RL. It's not deep reinforcement learning by releasing the algorithm trained to play Dota 2 and defeating some of the world's best players. This is Dota 2 is a game where it has the AI model has defeated the world's best player. So this is one of the popular algorithm which has based out of reinforcement learning. Okay, we will see the next one, Q learning or value iteration method. Okay, Q learning is nothing but it is a continuous learning in a loop. Okay, Q learning used to learn the action value function S and A. How good is it to act in a specific state? A scalar value is assigned to an action, a given state. Here we can see in the graph. Okay, what happens? Initially we will initialize the Q table, then we will choose an action, then we will perform the action, then we will measure the reward. Okay, then we will update the Q. If it is good enough, then we'll take the good table, good Q table. Otherwise, it is in a loop. It is like it moves in a continuous loop until unless our good Q table is obtained. So another type of RL is DQN. That's a deep Q network, Q neural network. Okay. So DQN is that what here what happens in a large set of space environments, defining a Q table would be very complex, difficult, and time. Instead of Q table, a neural network uses the approximate Q values for each function. That's not, but there are a number of inputs are there. Then learning will become difficult. So obviously at that time we'll take the help of neural network. Then we will define the Q value for each table. Then we'll begin the training. So another one is C51. This is another method of reinforcement learning. So in this algorithm, what happens is there is a distribution of Bellman equation is used, and there is a C51 workable algorithm that is being applied here. And the parameterization of the value distribution Z using 51 discrete values represented by the number 51. So 51 is a particular number which is defined and represented by the Z. Okay. So these discrete values will be obtained using C51. So this training will give you the based on the numbers of C51. So this is why known as C51 algorithm. Okay. So further down the line, we have another algorithm QRDQN, that is ultimate quantum regression DQN. Okay. In QRDQN, a distribution value is learned for each state of action, as opposed to establishing a single value. Here, complete pair is going to learn instead of single value. Instead of just looking at the average, the distribution value can help the policy. It follows that quantile are taught with threshold values in the cumulative distribution functions correspond to specific probabilities. So it is a probabilistic approaches. So here main approach is instead of single, will go in a action pair, state of action pair is done. So this is about a QRDQN. Next one is HER, that is a hindsight experience replay. In this method, a DQN is essentially given a state as well as a desired end state or a goal. It makes it possible to discover quickly when rewards are few. To put it another way, when the rewards are generally consistent with only one handful exceptional rewards values. In other words, end goal and starting both will be given, and it will be left to the algorithm to decide which is the best possible way with the minimum rewards. Okay, so that is done by using HER algorithm. So as we discussed earlier, there are one is model-based reinforcement learning. So in model-based reinforcement, what happens is this heavily influences both control theory, and the goal is to plan through function F, S and A, S is state and action, control function to select the best actions. Okay, and consider the reinforcement field where the creator provides the laws of physics. Okay, it is like applying a physics law and try to make the model learn. Okay, what is the disadvantage of the model is it is only limited to the specific task. Okay, despite the fact that they make more assumption approximation, but it is very limited. Okay, there are typically there are two approaches for this model based reinforcement learning. One is learn the model and other is given the model. What is learn the model? Learn the model means when the model is learn, we have to learn it from the beginning. Okay, there are basically few equations which are used. Okay, and we have to learn in proper way. And what is the given the model? When alpha given the model is the model is already given, okay, based on its previous training. Then we have to understand and try to learn from it. Okay, so given model has also defeated one of the AlphaGo Zero game player, okay, in the world, and it has become a very hype in the recent. So given the model has some very good advantage. So this another model, okay, learn the model. So these are the basically typical algorithms used in reinforcement learning. So now let us understand some merits and demerits. Okay. So what are the merits? Okay, reinforcement learning has the potential to solve extremely complex problems that conventional techniques cannot solve. So we cannot solve by using any machine learning and other algorithm, but RL has certain advantages for it. Okay, and another advantage is this method is preferred for achieving long-term difficult to achieve results. For example, DNA sampling and better routing. In this we can use. And this learning model closely resembles how people learn. Consequently, it is like a human. Okay, it will try to learn continuously. Then it will try to improve over the period of time. What are the demerits? Okay, reinforcement learning is based on the assumption that world is Markovian, which it is not. What is the Markovian? The Markovian model describes a series of possible events that probability of it determined solely by the state attained by the president. That is, there are certain conditions. It thinks that okay, these are the only conditions which exist in the real world. Other things are not. But in real case, there are n number of factors for any situation exist in the reinforcement learning training. And another one, the dimensionality curves severely restrict reinforcement learning for actual physical system. Dimensionality curves, no, there are n number of dimensions. If you go, then the training and merit everything becomes difficult. The training takes a longer time. Then the accuracy of that algorithm is also going to be challenged. So now let us understand some application where are these algorithms are used. One is a resource management in computer clusters. Here what happens, like for example in AWS, okay, when to increase the servers, okay, based on number of customers hitting an app, at that time we can use reinforcement learning. Another one is robotics, obviously, how to move from one place to another, do multiple tasks. Then is chemistry, like DNA sampling and another, and personal recommendation for like for example YouTube or Amazon Prime, like that. And finally is a bidding and advertising. So bidding and advertising, where advertising which one is best for a given audience, and bidding which price is very optimal considering the previous experience. So these are few typical applications which I have written. There are many, of course. So now come to the conclusion. The key distinguished factor of reinforcement learning, how the agent is trained. Okay, this is makes the RL distinguished from ML or deep learning, another thing. Okay. And rather than inspecting the provided data, the model interacts with the environment, looking for ways to maximize the reward. So it will not going to learn the data, it will try to interact with the environment. Then thereafter to try to obtain or learn it. Okay. Over the period of time, it will try to improve its efficiency. Okay. And finally, is a deep reinforcement learning involves a neural network that stores the experience and enhance the task performance. Like a DQL method, deep reinforcement learning, DRL. So in this, what happens? Whatever it learns, it will try to store in a neural network. Okay, weights and biases in terms of weights and biases. So when in future we want to overcome certain obstacle, so at that time our output weights and biases are readily available. On that we can train to this model to a further complex environment. So there is no need of training it from the scratch. So this is one advantages of using in neural network in the reinforcement learning. So this is all about types of reinforcement learning algorithms and reinforcement learning we have learned today. So thank you for joining.